Okay, today we're looking at what is probably the most ambitious map ever created. Seriously. Scientists working on this project called DESI, that's the Dark Energy Spectroscopic Instrument, have charted the cosmos in a way we've never seen before. And you know what they're starting to find? It could change everything we think we know about the universe. So just take a look at this image. What you're seeing, well, it's not a simulation. It's not some artist's cool idea. This is a real, three-dimensional slice of our universe. Every single one of those tiny little dots, that's an entire galaxy. And those threads you see connecting them, that's the cosmic web. It's like the very skeleton of the cosmos. And to even begin to wrap your head around the scale here, let's talk numbers. The DESI project has, so far, mapped the precise location of over 47 million galaxies and quasars. 47 million. I mean, that completely smashes its original 5-year goal, which was 34 million. It's just a staggering amount of data to work with. But here's the thing that really gets me. This map isn't just about space. It's also about time, because it's capturing light that has traveled for up to 11 billion years to get to us. DESI is, for all intents and purposes, a time machine. It's letting us look back and see the universe as it was, just a few billion years after the Big Bang. So the big question is, how on earth do you even build a map of everything? Well, the answer involves this absolutely incredible piece of tech sitting on a telescope out in Arizona. At the very heart of this whole operation is the DESI instrument itself. And get this, it's made up of 5,000 automated fiber optic eyes. And about every 20 minutes, these little eyes all swivel and lock on to thousands of new galaxies at the same time, just drinking in that ancient light. And the precision involved here is, well, it's just mind-boggling. Each one of those 5,000 robotic positioners can pinpoint a galaxy that's billions of light years away with an accuracy of 10 microns. Now, to put that in perspective, that is less than the width of a human hair. It's just an unbelievable feat of engineering, really. What's really remarkable is just how efficient this whole project has been. Think about it. They had to deal with a global pandemic. A massive wildfire actually swept over the observatory. And despite all that, the team still finished its main 5-year mission ahead of schedule. And they're not even done. The mission's already been extended so they can just keep on mapping the cosmos. Okay, so why? Why go to all this trouble? Why build this incredibly detailed, extraordinary map? Well, the answer lies in a hunt for what is probably the single biggest mystery in all of modern physics. The entire point of this massive project, the reason for all of this work, is to hunt for something that we know is out there, but we can't see it, and we really don't understand it. And that thing is dark energy. So, here's the deal. For about 25 years now, we've known that the expansion of the universe isn't slowing down like you might expect. No, it's actually speeding up. And dark energy is pretty much just the placeholder name we've given to whatever mysterious force is causing this acceleration. I mean, it's the most dominant thing in the entire cosmos, and we know almost nothing about it. Okay, so how does a map help you measure an invisible force? Well, it's pretty clever, actually. They use a sort of cosmic ruler. See, way back in the early universe, these sound waves rippled through everything, and they left behind these faint, sort of spherical patterns in how galaxies are all clustered together today. You can think of them like cosmic bubbles. And because these bubbles all have a known standard size, scientists can use them to measure huge distances across space and time. And this chart here, it shows exactly how DESI uses that cosmic ruler. By measuring how big these bubbles appear to be at different points in the universe's history, they can track how fast the universe was expanding over billions of years. Now, this specific pattern, this is what astronomers call baryon acoustic oscillations, or BAO for short. And that is the absolute key to measuring how dark energy has been influencing things over time. And this is where it gets really exciting, because after mapping the universe with more precision than we've ever had before, the first batch of data is already hinting at something truly revolutionary. I mean, just the first year of data alone was so compelling that the scientists on the project started throwing around phrases like major paradigm shift. One collaborator even said that, hey, if this holds up, it could be the most interesting discovery since we found dark energy itself. That is a huge statement. So let me break down why this is so significant. Our current standard model of the universe is basically built on the idea that dark energy is a cosmological constant, right? A force whose strength never ever changes. But DESI's data, it's giving us this really tantalizing hint that that might be wrong. It suggests that dark energy might not be constant at all. It could be dynamic, maybe even getting weaker over cosmic time. Now look, this is a huge claim. And the scientists themselves are the first to say, hey, we need more evidence here. This is not a done deal. The project is far from over. In fact, you could say this is really just the beginning of a whole new chapter in cosmology. So, what's next? Well, the full 5-year dataset is being analyzed as we speak, and we're expecting some really big results around 2027. And in the meantime, DESI is just going to keep on observing until at least 2028. It's going to grow this map by another 20% and add even more data points from further away to either confirm or, maybe refute these early game-changing hints. And all of this, it leaves us with a really profound question, doesn't it? See, all our theories about the ultimate fate of the cosmos, whether it ends in a cold, empty expansion or some kind of fiery collapse, they're all based on this one idea, that dark energy is constant. But if it's changing, well then the very destiny of our universe might not be written in the stars after all.